Okay, folks, example number 2. Hey, Miles. Thanks, man. I appreciate it. Miles found a mistake in this video the first time I did it, so let me try it again. I'm going to see if I can get it right this time. All right, looking at example number 2, it says factoring. Make sure the terms are in the correct order. Okay, let me scoot down here just a little bit. Now, when I say if they're in the correct order, I want to compare their degrees. And remember, degrees are it's the sum of the exponents of the variables. So this is 5. Okay, the 3 and 2 is 5. 4 and 1, okay, that gives us 5 there, and 2 and 3, that gives us 5 there. So the degrees are tied. So then I'm going to go alphabetically. If all of them have the same degree, I'm going to go by the alphabet, and I'm going to look at A. I'm going to organize it based on the A. So the highest A I've got is 3A to the 4th B. Then I've got plus 5A to the 3rd B squared. Then I've got minus 2A squared B cubed. Now you see it's A to the 4th, A to the 3rd, then A to the 2nd. All right, that's how I ordered it because they were all the same degree there. All right, now number 2, factor out anything you can, including a negative from the leading term. Well, the leading term is not negative, so I don't have to factor that out. There's no number that goes into all of them, but there is at least A squared, A squared, so I'm going to pull that out front. And there's a B in all of them. Okay, so what's left? Well, 3 times A squared, 3A squared. Okay, that would give me the first term, plus 5AB minus 2B squared. Okay, got that. Now, the next thing I need to do is look at what's left and count the terms. So I have 1, 2, 3. Okay? 3 terms inside those parentheses. So, if there are 3 terms, is it a perfect square? Well, I can look at this and see that it's not a perfect square because 3 isn't a perfect square, right? And 2 isn't a perfect square, so it's not that. Is there a number other than 1 in front of the x squared? Well, there is. There's a 3. Okay? So, yes, I'm going to use the guess and check, or I'm going to use the quadratic formula. All right? Now, with this one, guys, I think I'm going to have to use the guess and check because those numbers are pretty small. Right? I've got 3, so that's 3 and 1. And I've got minus 2, so I know I'm going to get minus 1, positive 2, or 1, and negative 2. Now, someone just walked in. I'm going to pause for a second, and then I'll pick it back up. Hang on. All right, now when I left off, folks, I had factored the 3, I had factored the minus 2. Now I just need to look at the pairs that I'm going to get here. I know I'm going to get 3 in the front, 3A and A. Okay? And I'm going to use minus 1B and plus 2B. Now I have to flip those two, so I've got 3A plus 2B and then A minus 1B. Okay? Now that's it for that pair. Now I'm going to do 3A and A. Alright, I know I'm going to use plus 1 and minus 2B. Then I need to flip them. 3A minus 2B times A plus 1B. Alright? Now, I need to multiply them. The thing I'm looking for is 5AB. Okay? So, remember, to do this, I multiply the outsides. That gives me 6AB. And the insides, minus 1AB. Alright, well together that gives me 5AB. So you know what? I'm actually going to use the same combinations but with different signs. Because this is what I want. Wait, that is positive 5. Exactly, so that I found it on the first pair. Alright, so now I've got A squared B times 3A minus 1B, or just B, and A plus 2B. Alright, now I'm not quite done. I need to go back up here. Alright, and the fourth thing I need to do is make sure when you think you are done factoring that each binomial or trinomial cannot be factored anymore. Well, when I look at these two things, that's prime. There's not even any squares in there. You can't pull out anything. Can't pull anything out there. So that's it. This is my answer. I have factored it completely. Alright? Nice job, guys. You ready for the next example? Hey, Miles. Thanks again. I think I got it right this time. If I didn't, let me know.